All right, excellent. So yeah, I'm glad that I can be here again, albeit virtually again. But yeah, at least I can be here today to talk to you a bit about, as Daniel mentioned, vector graphics. So it might not be like immediately clear why vector graphics at a Metabolomics workshop, right? Because this isn't exactly part of the data processing, right? It's not as fundamental as like feature-based molecular networking or statistics. But if you think about like what we've learned for the past week, we've been basically taking super complex data, right? We have tons of features. We often in metabolomics studies have many samples. So we've been getting really complex data, and then we've been making a variety of different visual outputs or visualizations from that data, right? So we spent some time making molecular networks. Then yesterday we did some multivariate and univariate statistics, and we came up with some really nice plots, right? Some PCAs, PCOAs, heat maps, et cetera. And so with all these figures, in the end, when we write a paper or give a presentation like the ones you'll be doing today, we of course are going to want to put these representations, either into our paper or into our talk. But in order to do that, we might want to actually change some small part of our PCA, or we might want to change the colors in our network. We might want to change something big or something small. And so how do we actually do that? So luckily we can use the vector graphic format and softwares that support that format to modify, to edit, or even to add to outputs from GNPS or from Jupyter notebooks. And so the big picture objective for this talk today, which I think will be a bit shorter than the allotted time, is really to understand first, what are vector graphics? How can they be made? And how can we modify them? So the learning objectives for today, as I said, are first, what actually are vector graphics? What programs can we use to modify them? And Daniel sort of alluded to this. How do we export vector graphics from GNPS? And then in the end, once we've modified or changed or added to our vector graphic, how do we actually export that for either our paper or for our presentation? Then how do we actually modify, scale, etc. vector graphics? And then I'll actually show you this in 2 programs. And then either at the end of this or have time to test this out on the figures that you generated earlier this week. If you want to modify them slightly, you can use the softwares to do so. And then the various instructors will walk around and help you if you have issues with that. But first, let's understand what actually are vector graphics, and then why do we use them? So some of you may have heard, I didn't actually see, how many of you have used vector graphics? I can sort of see you in the camera. Okay, so it's a little challenging to see, but I see the front row has some good vector graphic representation. It seems like not so many of you have actually used vector graphics. But I think this picture sort of clearly represents the differences between raster and vector. So raster graphics basically represent 2-dimensional pictures as rectangular matrices or grids of square pixels. As you can see here, you can see small pixels in this image. Vector graphics, on the other hand, though, are a set of mechanisms for creating visual images from geometric shapes on a Cartesian plane. And so basically vector graphics are represented by paths. And actually journals represent or request vector formats for figures containing line drawings and graphs. And so for that reason alone, it's important to understand and be able to produce vector graphics, because, if we write a paper, we're going to need to provide our images in the vector graphic form. So vector file formats include SVG, WMF, EPS, PDF, CDR, and AI, which stands for Adobe Illustrator. Now, I think the most common is probably SVG. Then raster file formats include JPEGs, PNGs, etc. All right, and so you've seen a bunch of analysis done in GNPS. And so both GNPS and Jupyter notebooks can actually facilitate the export of vector graphics. And so as you can see here, this is actually the MS2 spectrum of domoic acid, one of, as you probably know by now, Daniel's favorite molecules. And so here we can just pull up the USI for domoic acid, and then luckily we can actually just download it from GNPS as an SVG. And then once we have this SVG in hand, we can go to a software that will actually allow us to modify or edit this SVG. And so what softwares are these? Okay, so I think the most common are Adobe Illustrator and Inkscape. Now, I personally really like Adobe Illustrator and I've been using it for a long time, but Adobe Illustrator is rather expensive. I guess I feel it's worth it because I like it and I think it's great, but Inkscape is similar to Adobe Illustrator and it's actually the free version. So that is very convenient. And I presume a number of you in this room will probably be using Inkscape because not everywhere has licenses to Adobe Illustrator. But then finally, as Daniel mentioned, you can also make or modify SVGs in PowerPoint, though I think this might be slightly inferior to Adobe Illustrator or Inkscape. So today I'll just walk you through a bit of how we might modify SVGs in Illustrator and Inkscape, and we won't do PowerPoint for today. All right, so now I figure maybe we can just go directly to Illustrator. All right, so can someone give me a thumbs up if you see Adobe Illustrator right now on my screen? Okay, great. All right, so I thought that since yesterday we made some really nice heat maps, I thought we could start off by maybe looking at the heat map and seeing if, if we can maybe change a few things around in the heat map. And so one thing to note is we actually exported the heat map, if you can recall, as a PDF. Now, if you recall to just a few minutes ago, PDF is actually a vector graphic format. And so we can just open the PDF in Illustrator. I did this last night and then I just saved it as an SVG. And so just real quick, show you how to do that. You can just basically, it's quite straightforward. You can just save as, and then you actually have the option to just save as an SVG here. And that would be probably the format that's preferable for a journal. All right, so now I wanted to show you, when I open this up, there was no grid, but let's say I want to move stuff around in a way that's very organized. I can actually add this ruler here, this grid here, and let's say I didn't actually like this white background. I could get rid of it. And now I have my heat map in a grid. And so I could positioned, etc. But I actually like having the white background and yeah, and I don't know if I want the grid actually because it looks a bit, it's a bit of an eyesore for now, but sometimes I like using that. Okay, so I just wanted something I might want to change. I'm trying to make a publication quality figure. Let's see. So I might want to move these around. And as you can see, you can simply highlight specific parts of the image because it's an SVG. Now, in a PNG, we wouldn't be able to do this. And so maybe we just highlight these, and right now the backdrop is also highlighted, so we can get rid of that. All right, and now I can just move this maybe to be under here, and then, okay, that looks pretty good. And then let's say I don't actually like these white lines. We can just zoom in, and maybe we just get rid of them. We can just delete them. All right, I won't delete all of them. Okay, so maybe we sample something really handy that we can do, because we have this orange here and we want to change it in both.
Allegra, I think your connection is pretty bad. Maybe you can turn off.
Oh, it is?
To save bandwidth also. Yeah, it's freezing like now a little bit.
Can you hear me, or?
Yeah, but you were just like frozen for a bit. Maybe you can turn off your video in order to.
Oh, sure. I will try that. All right. Let's try again. All right, I just moved also to a different part of the room. Maybe this is better, hopefully.
I don't know. Any better?
Oh yeah, it's fine.
Okay, well, let's hope that that was just a lapse, because this part that I'm going to show you now is pretty nice. So just to reiterate, I'll go back a step because maybe some of this was missed. But let's say we have this heat map and we actually don't like the different colors of each sample. Like we just don't like this color orange and we want to change it. So we can just highlight the whole image, and then we can go to this Recolor artwork tool. Now we click on it. And we wait a second. Okay. And then we get this, we can go to advanced options. And now we basically have the ability to edit every single color that's in our figure. And so there's a lot, right? Because this is a heat map, but we just wanted to change this orange. And so here we have the current color, right? So orange, and then we tell it to basically change any orange to a new color, which we can say we want purple. Okay, and then we can just press OK. And then as you see, we changed the samples up here to purple, and we also, excuse me, changed the samples down here to purple as well. All right, so that's how we can change colors. We can also scale our heat map simply by transforming scale. So let's say we wanted to add some sort of schematic diagram next to our heat map. We could actually just scale this so that it would be smaller, and then we can preview what that would look like. Okay, so that's great. And then we can move this over here. And then in Illustrator, we could even start to draw this schematic figure. So we can use the shape tools here. Okay, if we want to draw a star and then I'm not sure what kind of schematic I'm drawing, but you know, we could have a polygon here, and the color is over here, etc. And then we can draw lines in between or an arc. Okay, and so I'm not going to bore you with every little thing in Illustrator because, yeah, there's lots you can do. But I think this is some of the basics that I wanted to go through. But then once we're done, we can simply, save this again as an SVG. And then it should be ready for a publication. But one other thing that I wanted to show was, let's say you ran some code in R and then you exported your plot, but by accident you exported it as a PNG, and then, I mean, this would be bad, right? Because it wouldn't be reproducible, but let's say you lost your code and only have this PNG. So what do you do now? Well, you can actually highlight it. You can go to image trace. Then you can do a low fidelity photo, and this will sort of start to ungroup the pieces, and then you can go to expand, and now you've actually ungrouped that. So then you can actually start to modify this PNG. So you can, for example, we can, it's a little more tedious this way, but we can delete this, for example, delete this, and then we could add new text in. So, etc. And then if we've modified this, then we can now save this as an SVG. And so we can sort of take a PNG that maybe we actually couldn't submit for publication because that object wasn't editable, and we can convert it into an SVG that will be acceptable for publication. And so just real quick, why do journals want SVGs? Well, if they have to make some sort of adjustment, like if they have to change the colors because maybe your colors aren't suitable for someone who's colorblind, for example, then it's really easy for them to do that if they have an SVG. If they have a PNG or a raster image, then it's less easy for them to do that. All right, so that's what I wanted to show you in Illustrator. Now, in Inkscape, we can do similar manipulations. So here I have the principal coordinate plot that we made yesterday. And I will say I'm less of an Inkscape expert, but I think there are instructors in the room who are typical Inkscape users. I know Kai is one. But we can, so here's our Inkscape image. Then we can basically go in and uh-oh. I'm gonna make, okay, sorry. let me, alrighty. We can go in and we can actually separate out the objects. And this will allow us to modify different objects separately. So let's say we wanted to change this text. So we could, instead of just principal coordinate plot, we want to write lab, oops. Oh no. So as you can see, I'm not as good at Inkscape. Lab 15, principal, or lab 15, DOM. Alrighty. Okay, so we can do this. And then if we want to change colors of any of these objects, we can, again, go, let's see. We can basically select. I'm just trying to find a good. Oh, sorry. I think it's because I'm on the, I'm not on the arrow. Okay. All right, so we can change the color simply by selecting, and there's a color bar at the bottom that has many more color options, and we can simply select a color here. And so, yeah, that's sort of just a brief introduction to Inkscape and to Illustrator. Now, I think, you know, we could go through everything you can do on both of these softwares, and oh, this is just what I already showed you. And it would take quite a long time. But I think the best way for you to actually learn how to use one or both of these softwares is to simply just take the outputs from the previous days in the course, the multivariate, the univariate, the networks, etc., and to try to make them as beautiful, we can say, as possible, or maybe not beautiful, but as clear and conveying as much information as possible. And I think using Inkscape and Illustrator really allow you to make images that are very clear, very nice for the reader to look at, much nicer than just the outputs from either GNPS or Jupyter Notebook alone. So I think that's really it that I wanted to cover for now. And Absar will be covering a bit more on SVG exports, but I guess for now, I hope you were able to catch at least most of this presentation. I hope the internet wasn't too bad. But for now, yeah, does anyone have questions?
Thanks a lot, Allegra. Maybe
Yeah.
before we get into the questions, there was one thing I was wondering if you could show that to people really quick, and that is also how to export then pixel-based figures
Yeah.
Inkscape, because yeah, while this is great for manipulating, once you have like a final thing and you want to throw this then into your, I don't know, like conference talk or so, then obviously like having a pixel-based graphic for that might be good. And maybe you can also mention quickly what type of like resolutions you would suggest for presentations or for like print.
Oh yeah. Yeah, that's a good idea. So yeah, here's our heat map image with our little schematic thing. So yeah, if that's a good idea, because for our final publication, we want the vector image, but for, let's say we're making a PowerPoint or a poster, we might need, yeah, a raster image. And so for that, we can simply go to export and then export as, and then we have the option to export it as a PNG or a JPEG or a TIFF. And so typically I think I would do a PNG or a TIFF. And so then you can export this as a PNG. And then as Daniel mentioned, it will ask you what type of resolution you'd like. And so you have various options, 300, 72, 150. So typically I would do 300 for a poster because that's, you want the highest resolution for something like that. For a talk, maybe a lower resolution might suffice, and that might help so that your PowerPoint is not just super, super large. So maybe 150 would be okay for that. Yeah, that's my 2 cents. In Inkscape, I said I'm not much an Inkscape user, but I suppose, yeah, we can export again this way. And yes, this allows us to export as a PNG. And then here we can specify the size of that. And then we can simply click export there. And oh, one thing also that I will note, I don't think I showed the last slide, but another good thing about these SVG generating software, or basically graphic softwares in general, is that, you know, they're not just used for one field like metabolomics, right? Every field, not every field, but almost every field, you know, generates figures. And so there's tons of really, really, really good tutorials on Illustrator and Inkscape. On Illustrator, there's like hours and hours of videos that you can watch online to do some really, really complex things. Daniel is really good at making sort of moving schematics and things like that in these softwares. And so you can really, I would say the sky is the limit for these tools.